welcome everybody. Today we'll be solving this paper. So this is 060621 May June 2023. So let's begin. So X and Y, I brought it. So you see this and you see this. Now you must stop at straight line. First I'm going to say y is equals to log y and x equals root of x. Now since it's a straight line, so this must be y is equals to mx plus c. Now you read it through the points. So these are 2 points. So these 2 points, so 5 is equals to m plus c and 8 is equals to 5 halves of m plus c. So you can see when I add 3 halves, it becomes 8, so 3 halves of m. Let me just change that to 3. 3 halves of m is 3, so m must be 2. So c must be 3. So log y is equals to 2 root x plus 3, and since they want y in this form, so y will be equals to 10 raised by 2 root x plus 3, which I can write as 10 cubed into 10 raised by 2 root x. So since they were in this form and a and b are the constants, so 10 cube is 1000 and then 10 squared is 100 root x. Then moving on to part B. Sorry, question 2. Okay, so sketch this graph of y is equals to g of x. So g of x 2 plus 4. So basically what I want you guys to do is that open up the fx991ex classes, go to table, option 9 table, and then you type this. So 2 plus 4 cos 6x, ensuring that your calculator is in degrees, and then you do from 0 to 120 degrees, and you can see every time you're increasing by 30 degrees. So you enter that, so it will automatically generate a table for you. So at 0 it's at, so this each of these lines is 2, so 2 4 6. At 30 it's at -2, 60 it's like 6 again, then -2, and then 6 again. So this means that this information will not be enough important, so you should crank it down to like 15. So at 15 degrees then we have like 2. At 45 we have 2. At 75 we have this, and 105 we have this. So why should I like put in 5 degrees every 5 degrees? At 10 degrees it will literally at 4. So at 3rd we are at 4. At 20, so at 20 we are at 0. Okay, you know what? We could draw this graph, and then so this graph is going to be more like this. And then this shape, I guess we could like maybe copy this. And yeah, I know it looks very weird, and that's why we're gonna use Desmos. So this is a graphic calculator app. So let's see, y was equals to 2 plus 4 cos 6x. Let me just check that. Yeah. And so it's in degrees, and it's for let's see, 0 degrees to 120 degrees. Why was I like brought here all the way? I mean, like, just you be like minus 10 to 10, and this is like 0, 120. They did not put in the right coordinates. This is like minus 10 to 10. I think I removed the x-axis. Yeah, that's why. I was just wondering what just like happened. So this is like, let me just mark these points over here. So like this, and this. Let's take a screenshot of that. Then this is our graph, properly sketched out graph. You know what, like, let me just like put this as a replacement for that. And then like, let's just erase this out. I mean, I know it was like a masterpiece, but I mean, what can I say? Okay, then so we need to find the amplitude of G. So amplitude is, I'm like, this is 4, so that's obviously 4. Okay, then this one, so what is the period? So how often does it like meet? So if you look at 30 to 90, that's 60. 0 to 60, that's 60 degrees, every 60 degrees. Okay, then we have this enormous looking graph and question. Let me like, can I like shrink the size of this a little? So that takes, I mean, obviously it should take up less space, so yeah, I think that's the best. Okay, so the diagram shows the graph of h of x. So h of x is this. We have these points. So minus 2, so x plus 2 must be the factor, and since it like bounced off really, so it's squared, so a must be 2 then. And then, I mean, this is really a simple question. And then for x is equals to like 1.5, so we'll have that 2x equals 3. So like 2x minus 3 is the factor. So then b will be 2x, and then c is like minus 3. Yeah, so these are the values, and we know that there is also like a 0, 12, so you can like also check by putting zeros. We'll have 2 squared into minus 3. Interesting. So it intersects at x12, but here, so we had just realized b plus c of x. So if I like put x 1.5, so 1.5 into -3, so b must be let me just change this. So c must be 2. 3 and literally this is like the most confusing question ever. Why? Because you know what, like, let's just move on to part B for now. Don't even want to talk about it. So use the graph to solve this inequality. And like the weird thing about this, I think they might have made an error either in the graph or in something else, because it is not possible for literally this. Like, think about it. X equals to 1.5, so 2x minus 3 is the factor. So when you put x0, so this is like -3 into 2 squared, and -3 times 2 squared is like -12. It's not 12, and here they have 12. So either, and like, what type of graph could this be, really? You know what, like, let's also graph this out real quick. Y is equals to x plus 2 whole squared into -3 plus 2x. So you can clearly see it intersects at 2 and -1.5. So you can clearly see that. But if I like suddenly change this thing to 3, so we have an intersection at 12, but now the root is like at -1.5. So I will like make the whole thing minus and then this thing minus. Like, I mean 3 and then -2x. So with 3 and -2x, then I think we have what our curve is looking like. Yeah. So then b, so this must be -2 and then this must be 3 for that to be true. So we can have either this or we can have 3 -2x as well. So this question was in a way like a trick question, to be fair. So yeah, that's what it was, just like. Okay, so for if x is less than or equals to 9, so first we have this point and this point, so between these 2 points it's less than 9, and then we have this point, so after this it's less than 9. So that looks like 1, this looks like -1/2, and this looks like -3. Let's note that down. So -3 is less than x is less than -1/2. Did I close decimals? No. So we will like also check with this. So y is 9, so this must be like maybe like let's put less than over here. So -3.5 and then 1, yeah. So can I like put multiple things? Like, I want this thing to be less than 9. Do you want to hear the sound? Where I want to hear the sound before we continue. Oh, that's fun. Method. So this is what this sounds like. This is like the slowest. So this, what are points of interest? These are the points of interest. Okay, whatever. So x is greater than 1. Whether it should be like this, so that's our answer. Okay, then this next question. So solve the equation. So 5 into 2y minus 1 is equals to 6 into this. So 5 into 2y minus 1 is like the same thing as 2 into 3 raised by y plus 1. So we have to give our answer correct to 3 decimal places. So you might be thinking that how on earth should we be able to solve this kind of a question? Well, if you watch closely, we know that 5 into 2, so we have two different bases. So you could try and graph it out, but you surely must think that there must be any other way. Well, why don't we try taking log 5 of this entire thing? Log 5 of 2 into 3 raised by y plus 1. So 2y minus 1 is the log of this 2 into 3y plus 1. So we know that. So how do we solve this? Well, if maybe we could try solving random values, but personally I don't think that will work. So the last solution is try with we could just put 0 in. So since it has to answers to 3 decimal places, so if you take a closer look at this, 2 into 3y plus 1, so this is 5 2y is equals to 10 into 3y, and then this is 5 2y is equals to 30 into 3 raised by y. So 3 raised by y and then 5 raised by 2y. So now this equation is starting to look a little more simpler. So I could say that 5 to the 2y over 3 to the y is the same thing as 30. So then y is ultimately just 1.604, and let's just check that. So it's 5 to this over 3 to this. Yep, that is 30. So 1.604 is the answer to this question. I mean this part. Then so how do we solve this one? So I will say that u is equals to e raised by 2x. So u minus 4 plus 3 over u must equal 0. So u square minus 4u plus 3 equals 0. And since we want all the answers to be in an exact form, so since they must be in exact form, so our only choice is to use factorization. So we could write this as u minus 3 into u minus 1 equals 0. So e to the 2x first of all must equals 1, so x equals 0, and then e to the 2x is equals to 3, so x is equals to half of ln 3, or you can write that as ln root 3. So these are two answers. Okay, then moving on to, I think, question number 5. Yeah, so question 5. So this is the volume of a sphere. So it's increasing at a constant rate. Find the rate of increase of the radius. So dr by dt. So I could write that as dr over something into something over dt, where this is like d and d of something. So since we have the volume, why don't we like just try using volume? So volume and volume. So what's dv by dr? Well, that's like 4 pi r squared. So dr by dv must be 1 over that. So 1 over 4 pi r squared. Now when r is 6, so dv by dr is going to be equals, sorry, dr by dv, I wrote it the other way around. So 6 squared is 36 into 4, so 1 over 144 pi, and then dv by dt is like 24. By this thing is dv by dt. So to find dv by dr by dt, it's going to be 1 over 144 pi into 24, which is like 24 over 144 is like 1/6, so 1 over 6 pi, or 1 over 6 pi is 0.053, which is our answer for question 5. Okay, then moving on to question 6. So the position vectors of these points relative to the region O are this, and this respectively. So point R lies on PQ intersectant such that 3 times QR equals 2 times PR. So QR, let's write this down. So what could QR be? So to like find QR, simply we are going to do OR minus OQ. OR minus OQ. So OR is going to be equals to QR plus OQ, and and then for PR, so we can find QR, which will be OR minus OQ, as I said from before. Interesting. QR, if I okay, leave QR for a sec. So now let's put let's try putting PR. So PR is going to be equals to OR minus OP. So OR is equals to PR, OP plus PR is PR. So I know that 3 times QR, so 3 OR minus 3 OQ. 3 OR minus 3 OQ. OQ is equals to 2 OR minus 2 of OP. So basically OR is like 3OQ minus 2OP. So OQ is like this thing 8 and 5, whereas OP is like 4 and 7. So 24 minus 8 is like 16, and 50 minus 14 is 1, so therefore x equals 16 and y is equals to 1. So that will be our answer. Okay, then we have this question. So you are given that I is so I have a mnemonic: never eat slathered wheat. So it's like going clockwise: never eat slathered wheat. I mean, like slathered, it's like as if it's like very weak wheat. I don't even think slathered is even like a word, but I mean the rest of the three are, so it's a really good mnemonic. Never eat slathered wheat. So three vectors A, B, and C are in the same horizontal plane as I and J. That A plus B equals C. The magnitude and the bearing of are 5 and 210. C is 10 and 330. So A, B, and C are in the same horizontal plane. So they're in a horizontal plane. So magnitude and bearing. So A is like from north. It's going. So A is like going somewhere over here. This is A. And then from north again. Let me just copy this arrow. So from north again, C is going 330 degrees, like this. It's like travel 270, and then 270 plus another 60, like over here. So that will be like somewhere like this. So this is 330 degrees. This is C. This is north. This is also north. And this is 210 degrees. So basically here so minus x and minus y, so x and y are both negative over here, and here we have minus x but y is positive, so that's what we have. So we'll have 5 sine 210, which will be minus 5 halves, and then 5 cos 210, which is again negative. So A will be minus 5 halves of I minus 5 root 3 over 2 of J. So that's going to be A. And then for finding out what B is, so sorry that my screen sometimes rotates. I mean, it's been a part of my videos for 2 to 3 times. I'm really sorry about it, but I'll try not to rotate it. And that's all I can do for you guys. So and then for C, for calculating C, we're gonna have to find so we're gonna do again the sine cos method. And by the way, I just realized that these two should be swapped for each other, so someone like this. That's what it should have been. Yeah, do cos and then sine. So then the other one is going to be 10 cos 30, so which is I'm actually starting to question myself because 330 degrees, you're going clockwise, right? So clockwise of a 330 degrees is like over there. In this direction, here's minus x comma y. And like it's obviously positive, but for some reason it's like negative out. So it's like going like 5 root 3i minus 5j. So this is a bit interesting, but we're gonna have to accept it for now. So let me just like also like recheck this before we like move on with the next question. So they told us that these are the magnitudes. Yeah, so just a minute, guys. Realize that it's the other way around. What I was doing before was correct. So it's the other way around. So like this, and then minus 5 over here, and 5 root 3 over here. So that's how it's just a minute again. So yeah, so that's how it's supposed to be. And then with the other one, it's basically so you have like, so for part 2 of this question, so we're basically we're gonna add these together. So what I can really comprehend over here is that so you've done like c minus a. So once you've done c minus a, and then you're gonna solve it like that till you like solve and get the answer. So yeah, so for b is equals to c minus a, b is equals to minus 5 plus 2.5i, and then like 5 root 3 and then plus 5 root 3 over 2 j. So b is equals to minus 2.5i and like 7.5 root 3 j. So now we just need to like find out the magnitudes. Like we just like square these and then sum them up. And then take the square root of that, so that's like 5 root 7 or 13.2. And then theta is, so you'll first like you're likely gonna do like tan inverse of 2.5 or 7.5 root 3, or you could like do it the other way around, which is like just gonna be 90 minus that. So the bearing eventually is going to be like 349 degrees. So these are your answers. Then So question 7 now. So how do you solve this? By the way, make sure to like, share, and subscribe to our videos. And let's get back to it. This is the area. So this is the area that's gonna be shaded by this quadratic, and then we only want this whole area. So what have we done? We've cut this triangle out. So this is 5, this is 5. So basically first find the integral from 0 to 5 of 6x minus x squared dx. So that's gonna be like 3x squared minus x cubed over 3 5 0. So 3 times 25 is 75 minus 125 over 3 minus 0 minus 0, sorry, plus 0. So 75 minus 125 over 3 is 100 over 3. So this whole area was 100 over 3. And we basically have 100 over 3 minus 25 over 2, which is 125 over 6. That is the area of the shaded region. Okay, then moving on. So this one, so we can like split it to integral of 1 over 2x minus 6 whole thing cubed, and then dx, and then the integral of like cos x dx. So here this is like u. So first we can have like sin x, and then so I can call like u is equals to 2x minus 6. So like du by dx is like 2. So dx is like half du, and then when you like go to integrate 1 over u cube du, du, so you like and then half outside over here. So this is like u to the minus 3, so it goes to the minus 2. And once it's to the minus 2, you divide it by minus 2, so you like get minus 1 over 4u squared plus c. So this is like minus 1 over 4 into 2x minus 6 whole thing squared plus c plus sin x. So you can call it like sin x minus 1 over 4 to 2x minus 6 whole squared plus c. That's your answer. And then so find this. So what you do here is that you basically want to like expand the above thing. So this is what you get after expanding, and then you just want to like divide individually each time by x. So you get like x 7 over 2. Here you get 2x cubed, and here you get like 1 over 2x. So you obviously you're gonna like integrate these individually. So like x to the 8 over 16, and then x to the 4 over 2, and then this is like integrate to I think like half of ln 2x. Let me check. So with my calculator, so the integral of 1 over 2x is ln x, so it's half ln of x. So and then this is like plus c. So yeah. Okay, then moving on to the next question. So what do we have here? So given that f is like a 1-1 function, what is the domain and range of f inverse of x? So we know that we know what f of x is, so we just need like solve. So first I'm gonna say that x is equals to 3y or the square root of 5y plus 1, and so by the way, the domain and range, so the range of f inverse of x is going to be for this thing, so the domain of that is the range of this, and the range of that is the domain of this. Yeah, so here we can then do 5y plus 1, and then all of this is 3y. So now if you observe something, f of x was 1 to 1, but it's like a composite function. So we have one function and then we have another function. So this is a bit tricky to solve. Why? Because we need to like have all the y's. We don't want it to be, basically in simple words, if I like do this with power half, then this is like 3y, but I want all of the y's to be on the other side. So maybe I should like try doing this, which is going to be 3y into the square root of 5y plus 1. And so since we want like, so maybe I have an idea. What if we say that going back to over here, so x I could say is like 3y into 5y plus 1 to minus the power of half. So to get rid of this thing, I could multiply it by this. So all of this is equals to 3y, and therefore I could find whatever f inverse of x will be. So since it's 1 to 1, so we know that it's going to be somewhere like this. Let me just check up on part B as well. So basically this is like the part where we have to like solve for f of x equals x. So like this. If I like say that all of them are the same for 1 second, root of 5x plus 1, so then I could like literally solve this as root 5x plus 1 equals 3, so 5x equals 8, so x is equals to like 8/5. So that will be simple, but here we have two different variables. We have a root of 5y plus 1 and we have the 3y. Didn't I like solve the 5y puzzle? No. Okay, so to find the f inverse of x, is going to be the y. So and like have all the y's on one side. So yeah, so so this will like be 5x squared y plus x squared equals 3y. So I could like do 5 into x squared y plus x squared equals to 9y squared. So x squared and like, so 9y squared minus 5x squared y is equals to x squared. So y into 9y minus 5x squared is equals to x squared, and therefore we can like find out f inverse of x. So this is like the challenge for you. Okay, so how do you solve this? So we can go about this like that. So this is x, and so 3 is equals to root 5x plus 1. So 9 is equals to 5x plus 1. So I'm like x is equals to 8/5. That will be the answer. And so on the diagram above, sketch the did I take the picture of the diagram? No, I didn't. So 3x over root of 5x plus 1. So 3 f of x is equals to let's move on to so let's just like move on to part B. So the functions g and h are defined by this. So what is the expression for this I can say is like x cube is equals to 8y cube plus 3. So 8y cube is equals to x cube minus 3. So y cube is equals to x cube minus 3 over 8. So g inverse of x, and I think for this they wanted the domain and range. So the domain range I know is going to be 0 is less than or equals to f inverse of x less than or equals to 3. Wait, I think that enlightens me with an idea which I might test later on. And the range of this function, well, the range of this was for this one it was like going endlessly, therefore like you can put in any value. So instead of like drawing the complex r, you can like just draw it like this. So a line and then the normal r. That's also going to be accepted. So this is the domain and this is the range. So since you can like put in any value for like x is greater than 0, for example, or wait, I think the range, so it's like also going to be dependent on that. So 3 into 3 over root of 5 into 3 plus 1. So this is like 0 less than or equals to x less than or equals to 9/4. So this is the range. So you can put in all of this stuff into y. So I'm assuming that after this the loop just like breaks. So this is going to be the domain and this is going to be the range. So okay, let's just move on. So g inverse of x is going to be cube root of x cube minus 3 over 8. Okay, then find the value of k for which g of h can be found. So for g of h, how do I write g of h of x? So this is like going to be the cube root of 8 e to the 12th power of x, e to like 12x, e to the power of 12x plus 3. So since x must be like greater than a certain value, so x could be like literally anything, but for it to have an inverse, so what is the curve of like e to the power of x? So this is what the curve, sorry, this is the x-axis, not this. So it's basically like mainly like going like somewhere like this, but it like never can reach x0. So again, so k must have the same requirement that for 1, so k must be, let's say, like greater than or equals to why don't you put like, so for e to the power 0, it's, since x must be greater than or equals to 1, so 8 plus 3, so I know that e to the 4x, so e to the 4x must be greater than or equals to 1, so 4x must be greater than or equals to the ln of 1, so x is basically greater than or equals to 0, so I could say that k could be equals to 0 for it to be 1, so yeah, k is 0 basically. Again, so find and simplify the expression. So basically this is g of h of x, by the way. Okay, so in this question, all the lengths are in centimeters and all angles are in radians. So the area of a sector of this circle is 432. So half r squared theta equals 432. So what's 24 squared over 2? So 24 squared over 2 is 288. So 288 theta is equals to 432. So theta will be 432 over 288. So it will be 3 halves. So r theta. So what's 24 over 2? That's 12. So arc length will be equals to 36 centimeters, and this is like our radians. Okay, then on to this weird triangle. So finding expression for OB in terms of y and a. So the diagram shows this isosceles triangle. So OA equals OB. So this is why this whole length. Put that over here, yeah. So OCD is the circle with the center O. So is it the same sector? No. So angle AOB is alpha. So to find OB, by the way, I know that this is also alpha. And this is basically going to be like 180 minus 2 alpha. The side, because I just found out that OD is literally one of the lengths of the triangle. So So OCD is the sector, and since you can observe there's a triangle sitting right angle triangle sitting right over here. So according to this, it looks like so cos alpha is the base over the hypotenuse. So the base, or which I think you guys call it the adjacent. So the base or the adjacent is going to be the hypotenuse, which is y cos alpha. As simple as that. Okay then. So hence show that the area of the shaded region can be written as this. So what is the area of this triangle going to be? So this is what y cos alpha, this is y cos alpha, and this is y cos alpha. So the area of OCD is going to be equal. So for OB, so since the base is this, so I'm gonna have to say that OB is equals to 2y cos alpha, because this was this, so this must be this. So and you have to sum them up. So yeah. So this is going to be y squared over 2 half r squared theta. So basically 2y squared cos squared alpha, and then an alpha over here. So let me fix that alpha, which is going to be 2 alpha y squared. Okay, then so that's the area of the shaded region. But what about the area of the triangle? So basically for the area of the triangle, you're gonna do half into y into 2y cos alpha. This cancels out into sine alpha. So this is going to be equals to y squared cos alpha sine alpha. And since we have this, so y squared cos alpha sine alpha minus 2 alpha y squared cos squared alpha. So we could factor out y squared to make it, and then a cos alpha to make sine alpha. So this should be half, I think, because if you factor out the 2, so this becomes the 2, and then the y squared removed, and so you're left with a cos alpha. Yeah, very complicated. Okay, so I challenge you to be able to solve these without my help, obviously. So this is a 10 marker, this is a 9 marker. So play the video once you're done with both of these, and if you can solve these, congratulations. If you can't, then play the video, and also do leave me a like, do subscribe to the video, and do comment. So okay, so let's move on with the video. So let's move question 10, so 11, and solve 10 first. So in this expansion, where a and b are constants, the term independent of x is this, and the coefficient of x to the power 6 is this. Show that a squared b is minus 12 and find the value of a and b. So first things first, so to find the term independent of b, so you can like make the whole like a whole table, so x and x squared, so 9 0, this is 8, so this is 2, 7 4 6 6, so yeah, so this is going to be 9c0, 9c1, 9c2, and 9c3. So the term we'll have 9c3 into ax raised to the power 6 into b over x squared cube. So all of this is going to be equals to this thing over here, and let's find what 9c3 is. So 9c3 is like 84. Let's do this thing over 84. So I know that a to the 6 and to b cubed is minus 1728. Interesting. By the interesting fact, did you know about the Hardy-Rangeman number? So basically they call it mostly Rangeman's number. So it's the smallest number for which two different cubes sum to give you the same number. So this is also equals 1729, and let me check 12 cube. Yeah, so that's also, so this is also 1729. This is the Rangeman number. Okay, so now the coefficient of x to the power of 6. So x to the power of 6, so 9 minus 0, 8 minus 2, this so 8 minus 2, so now 9c1 into ax to the power 8, ax to the power 8 into b over x squared is equals to minus 6912, and 9c1 is just 9, so 6912 over 8, sorry, 9 is so basically a8, ignoring the x's, so I'm not going to write down the x's. So a to the power 8 into b is going to equals to minus 768. So how do we get to this? Well, we could maybe, I'm just giving an idea, maybe we could divide these. So if you like do a6b cube over a8b, that's like minus 1728 or minus 768. So what's 1728 over 768? Well, that's like 9/4. So I know that b squared over a squared is 9/4. So therefore I can say that a squared, sorry, I can say that b over a, the whole thing squared, is 3 over 2 the whole thing squared. So you can like officially say that I have found that b over a equals 3 halves. So therefore 3a equals 2b. So let's do like b is equals to 3a over 2. So now we can put it into this equation. So 3a 9 over 2 is minus 768, I think. let me check. Yeah, so a to the 9 is going to be, so minus 1, so multiply by 2 over 3, so minus 5 1 2, and then so a is going to be minus 2, so minus 2 to the 9. Yeah, and since b was this, so b is going to be minus 3. That explains why both of these were negative. So a is minus 2 and then b is minus 3. So that is our answer for now. Okay, then finally question 11. So this line is a tangent to this curve. So 3y is like k minus x. So y is equals to k minus x over 3 is a tangent to this. So find the value of k and hence the coordinates of the point where the line touches the curve. So x squared plus k minus x over 3 whole thing squared plus 2k minus 2x over 3 minus 9 equals 0. So x squared plus k squared minus 2kx plus x squared over 9, and then 2k minus 2x over 3 minus 9 equals 0. So multiplied by 9, so we have 9x squared plus k squared minus 2kx plus x squared plus 6k minus 6x minus 9 equals minus 81 equals 0. So 10x squared and then looking for x's, so plus this minus 2k minus 6 I did this and then finally k squared plus 6k minus 81, so all of that is 0. So b square minus 4ac equals 0. So 2x plus equals 0. Not, I think I said equals 0. Yeah, minus 4 into 10 into this whole quadratic equation of terms must equal 0, and by the way this is k. So 4k squared and then 2 into 6 into 2, so 4 into 6 plus 24k plus 36 minus 40k squared, and then 40 into 6 plus minus 240k, and then plus 81 into 40 is 3240 equals 0. So take it to the other side. So 240 minus 24 is, this will be 216k squared, and then 36 minus this thing is 3. So if we try and divide everything by 36, so we're going to end up with k squared plus 6k minus 89 equals 0. Let me just solve that quadratic for you. So did this say find the value of k? So k is positive constant, so k must be equals to like 7 equals to minus 3 plus 7 root 2, or which is 6.90. So find the value of k, and therefore we need to find the coordinates of the point where the line touches the curve. So where exactly is the line even touching the curve in the first place? So since we now know the value of k, so we could try and solve the quadratic equation. So let me call this a. So we have 10, then minus 2k minus 6, and then we have k square plus 6k minus 81. So after putting that into the equation, so either we have x equals to root 2. Find the coordinates of the point where the line touches the curve. So x is equals to root 2, or x is equals to 2 root 2 over 5. So we have two possibilities. So if we like do a minus root 2 over 3, and then the 2 and this thing. So we could have like root 2 comma minus 1 plus 2 root 2, or 2 root 2 over 5 comma and then root 2 minus 5 over 5. Those could be our answer. Thank you guys for watching, and I'll see you next time. Bye.